Everyone, welcome to Baozi Training Leetcode solution. If you want the best marketing video experience in North America, feel free to check us out at baozitraining.org. We provide software engineering mock interview, for example, one round of 1 hour interview, one-to-one to the top tier engineers from the top tier companies, and with a 30 minutes debrief and a Q&A. Or you can buy 3 rounds of mock interviews. Each contains a one-on-one interview with the either hiring managers or the bar raisers or the real interviewers from those top tier companies. Each round has a 30 minutes debrief, and also you will have a resume revision with very senior engineer or hiring managers. All right, so let's jump to the problems today. So today we're going to talk about this problem, Leetcode 124 binary tree maximal path sum. So what is the problem? First of all, we have a binary tree. Note it's not a binary search tree. And then we want to find a sequence of nodes from where starting node to any node in the tree along the parent-child connections. And then the path must contain at least one node and does not need to go through the root. And then the path sum needs to be maximal. So essentially, it doesn't need to go through the root. For example, in this example, like 15, 20, and 7, those are the maximal sum, path sum. It doesn't need to go through 10. So the thought process of this problem is whenever we're dealing with binary tree problems, right, traversals should be our first thought. There's essentially pre-order traversal, in-order traversal, post-order traversal, and there's also level order traversals. It seems to should be relatively natural to think this could be a post-order traversal. Essentially, whenever you are on current node, right? For post-order, it means is you already process the left, you already process the right, and then you process the current node. You already know, for example, the maximal path of the left part. You also know the maximal path of the right part. And now, how do you calculate the maximal path? Let's assume everything has to go through the root node. So that is essentially, the current node could be the maximal value, because let's say this is a negative number, this is also a negative number, so this 20 is actually the largest. So this is one chance. Or it should be the maximum of the left sum of the left path and also maximum of the sum of the right path, the max of these two. Essentially, which one is larger, we'll just pick this one, and then plus the current node value. So in this case, this left path is the largest value. This will be very simple if it has to go through the path. So essentially, you keep recursion, and then once you go to this end, you will know what is the left part, right part. The maximal value is either itself or it plus the maximum of either the left subtree or the right subtree. The tricky part is it doesn't need to go through this, right? This is a great example. So this is actually the maximal path. All we need to do is once we have the single path max, we just need to use the single. We need to get a maximal between the single path max versus the left max plus the current node, and then also plus the right max. Essentially, is this formula here. So this compares the existing single path maximal value and also this path. However, just keep in mind, whenever you return, the caveat is you should always return the single one, right? You should never return the current maximal. Why is that? So this is the example, right? So you already know this is the maximal path. So this is the maximal path. You know the left path, like the maximal of this is 35, and the maximal of this is 27. So whenever you return, why you should return essentially 35. Why is that? Because on this path, if you include this maximal value, and then let's say there's a path, you could return this, but then it is not a path from a node to another node. Then you have to go through this, and then you have a branch. You have to either go left or right, so that's not valid. So you can always record this as a maximal value, but you should, in your recursion function, you should always return the path, the single path maximal, which is either this one or this plus this or this plus this side. So if you look at the code, if there is null, return 0, so this is a single path. Single path is, like I said, is either root itself or the maximum between left and right plus the root itself. And then this is the value you should always return. However, you need to also calculate this single path between the left plus right, also plus the root. And then you record this maximum value. Oh, I think I messed up the indentation. The time complexity is O(n) because each node is only weighted once. And the space complexity, I always like to say, it doesn't need any extra space. Well, it does use recursion. So if you counted the recursion function stack, then it will be O in terms of log n, where n is the total number of nodes, which is essentially the height of the tree. Okay, it's a relatively straightforward problem, even though it's rated as a hard problem, but I don't think it is hard. This is at most a medium for interviews. Leave any comments if any questions. Until then, see you guys next time. Bye.